Yo, I know you have been waiting for JEE question, and here is the JEE 2019 question. The lucky batch. A particle starts from the origin at t is equal to 0 and moves along the x-axis. The graph of velocity with respect to time is shown in figure. So directly this figure is given. Just do not read the story. What is the position of particle at t is equal to 5 seconds? So it is given here 5 seconds. Velocity is 3 meter per second. Can we find directly? Can we find directly? Four options are given. Yeah, we know that very simple. Distance is area under speed. What is the area? This is the area. 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 Up to this. Up to this. So first for the first portion, one by two. It is triangle. So height it is two multiplied by two. Two cancel. So it is two plus plus this square plus this is the square, this is the square. So plus 2 multiplied by 2, 4. Plus what is this? This region. 3 multiplied by 1, it is 3. Wow, 3 multiplied by 3. So solution is 9 meter. 9 meter is the correct answer. This is 2 plus 4 plus 3, 9. This is 9. Correct answer is correct. Wow. Then 21, example number 21. Oh, again, JEE 2019 means we have already solved 20 examples before that. I think you should try by yourself. Why not? This is not difficult. What it asks, a particle starts from origin O from the rest and moves with uniform acceleration along the positive x-axis. Identify all the figures that correctly represent the motion. Right, quantitatively, A is acceleration, V is velocity, X is displacement, T is time. It was asked in JEE mains. Option A, option B, A, B, C, option C, B, C, option D, A, B, D. Fine. So what is mentioned here? First is uniform acceleration. First, it is given acceleration is uniform. Right? Acceleration is uniform. Matlab constant. Meaning is constant. Positive, negative. It is second dimension. So acceleration graph is given here, and it is giving acceleration is uniform, acceleration is constant. So yes, graph number A is correct. So where it is, we can find A is given here, here. This C is not given, so it is wrong, and this is option. Okay, we have now three options. Fine. Then let's check velocity versus t graph. If we see that if acceleration is constant, right, and velocity is starting from zero, so we know that if this is the straight line, that should be an inclined line with the positive. So here this graph is correct, B is correct, B is correct, B is correct. So only A is given, so this one is not correct. B is given here, this is the correct, and this is the last one is correct. Right. Then let's check C. Okay, fine. So acceleration is positive. So what should be the graph? Graph should be concave. Final graph should be concave. This is concave. No, this is concave. Yes. D is correct. Where is D? D. Wow. So answer number D is correct. So here, let's again solve. A is positive, constant. So this graph is correct. Graph 1 A is constant and positive, correct. Graph B, graph number 2, V is increasing linearly, positive, correct. Yeah. C incorrect because the shape is convex. But A is positive, A is positive. Therefore, shape should be concave. And then also we can find angle also. You can play with angle also. Velocity is positive, so theta should be less than 90 degree. And graph 4 starts from 0. Shape should be concave. It is there. And this is the solution. This is it. If you remember the tricks, for the concave and convex shape, and A positive and negative. You need not to solve everything. You will get answers much quicker. Answer is D, A, B, T. We already identified this answer. Example number 22, the velocity time graph of a stone thrown vertically upward with an initial velocity u is given 30 meter per second. Okay, shown in figure. So here it is initial velocity u is given. Shown in the figure, the velocity in the upward direction is taken as a positive and that in the downward direction as a negative. That is, we know it. We know it. What is the maximum height to which the stone rises? See, we already seen this kind of velocity versus time graph, and this always when there is a velocity is equal to zero. See, when stone is thrown from the ground, upward direction, it reaches to maximum position where momentary velocity becomes zero, v becomes zero, and then it goes to return, increasing velocity. Right. So here, whenever you find this position v is always a maximum. So displacement, you just need to find this displacement, nothing else. Velocity multiplied by time gives displacement. The area under speed time graph gives displacement. So height is 30 and the time is taken 3 seconds divided by 2. So it is 45 meter. 45 meter is the correct answer. I announce that 45 meter is the correct answer. Not it down. Then example number 23 again OJEE 2017 mains. The body is thrown vertically upward. Great. Body is thrown vertically upward. Which of the following graph correctly representing the velocity versus time? See, let's draw the graph. See, when the body is thrown upward, so acceleration is equal to minus negative. And when we draw A versus T, so we know that graph is gives minus G. If this is the graph where initial velocity is positive, so V is positive, acceleration is negative. So what happened? What happened? So velocity is positive. Say for example, this is initial velocity positive, right? And then acceleration is negative, so it reduces, straight line reduces. Can you compare V? Wow, answer is B. Answer is B. A is negative constant, U is positive, so V is decreases linearly from the positive. V decreases linearly from the positive and it keep on decreasing, you cannot have two velocities at the same time. No, you cannot have. So B answer is correct answer. B answer is correct answer. Only logic is required when you talk about JEE questions. Oh, one more questions we got. The time velocity graph of a stone thrown vertically upward with an initial velocity. So let's have one more example. Example number 25. If t is equal to 0, u is equal to 5 meter per second, a is equal to 5 meter per second square, then velocity after. See, you can solve all of the above examples with the use of equations. Yeah, yes, really, you can solve. Why don't you comment your answer? So we know that v is equal to u plus at, put the values, v is equal to 55 meter per second. Or you can solve this graphically also. So at t is equal to 0, it is given u is equal to 5 meter per second. Acceleration is given 5 meter per second square. Then velocity t is equal to 10 seconds. So v is equal to u plus change in the velocity. That means area under this section we just required 5 multiplied by 10. So it becomes 55 meter per second. So easy. So easy. Then example number 26. The speed time graph of a particle moving along a fixed direction shown in the figure obtain the distance transverse by the particle between t is equal to 0 to t 10 second, v t is equal to 6 second. What is the average speed of the particle over the interval a b in b a b a b? Great, great, great. So we just need to have average speed, nothing else, right? So t is equal to 0 to 10 second, and t is equal to 6 second. Good. So change in the displacement is equal to starting from 0 plus area under this region. One of this total height is given 12, and this is 10, 60 meter. Average speed of the particle. Distance we got. We need time. X is equal to v is equal to x by t, and therefore 60 by 10, that gives 6 meter per second. Average speed of particle over interval a to b, it is 6 meter per second. It is 6 meter per second. One more question, example number 27. The displacement time graph of moving particle is shown below. Oh, the instantaneous velocity of the particle is negative at a point. We just need to find the point where instantaneous velocity is negative. All India pre-medical test 1994. Very simple question. See, for the instantaneous velocity, if it is negative, we just need to find the slope. So what about slope at C? It is positive. Slope at T, it is approximately 0. Slope of E, slope of E, slope of B, slope of E, it is theta is greater than 90 degree. That means it's a negative slope. And the slope of F, it is again theta is less than 90, so it is positive. So only slope at E is negative. Slope at E is negative. So D slope is 0. E slope is negative. We already seen this is the E slope. This is E slope. This theta is greater than 90 degrees, so it is negative. C and F are positive. C and F are positive. We already checked this. C is positive because this theta is less than 90 degree. For F also, this theta is less than 90 degree. So we know this. T slope is 0. So which answer is correct? Answer number D is correct answer. E. We got one more question. Example number 28. Which of the following curve does not represent motion in one dimension? All India pre-medical test 1992. So first one, see, velocity increases, velocity decreases, it is okay, no issue at all. In the B, velocity increases non-linearly, that is okay. But see, option number C, velocity at particular time, two velocity is not possible. There are two velocities are not possible at particular time. Therefore, this option is incorrect. D is also okay, no issue with this. Then, example number 29. Look at the graph A to D carefully. Yes. And state with reasons which of this cannot possible representation of one dimensional motion of particle. We are studying one dimensional, and this is from your book NCRTE. Wow. So first case, let us see first case, time is going in the negative direction, time is going in the opposite direction, and at time t, it is showing distance x, and this is another distance. Oh, wow, is it fair? At time t, two distances are not possible. See, I cannot be here and in America, both the places I am not. It is not possible. So therefore, A is not possible. B, time t, there are two velocities. We already seen this case. Two velocities at the same time. It is not possible. It is not possible. Then next you see here, this is the very tricky. If it was a velocity, then it is a correct. But here it is speed. Here it is speed, and speed cannot be negative. Speed is equal to distance, total distance divided by time. Therefore, it is not negative. See, Such kind of tricky question will have a speed word in the question, and there is a great chance to get mistake. Do not make mistake. And the last, total path. Total path cannot have in the negative direction. It is always summation. Total path is the total distance travel. You cannot travel negative. If you travel negative in this total path, you have to add. You have to add. So this is not. And again, last C and D are having higher chances to get some mistakes. Do not make mistakes. Then example number 13, velocity time graph. Figure shows that x plot of one-dimensional motion of a particle. Is it correct to say from the graph that the particle moves in a straight line for t is less than 0? We are talking about t less than 0 and on a parabolic path for t greater than 0 if not suggest the suitable physical context for this graph. NCRT. Do not forget to solve all the NCRT books, all and unsolved. Read each and every word of NCRT books. So graph it is given. See, it is incorrect to say. It is incorrect to say that. See, it is given like that t at negative t, negative t, negative t. It is not having, or you can say object at rest, and then it moves on the exponential part non-linear. See, this statement is not possible because of only one time direction is given. There is no data is given for the x direction. Therefore, this is not possible for that. If you suggest that, so time is less than 0, so here object is at rest because x is 0, object is rest. And then after if there is an increase, so we just need to find the slope. Theta is less than 90 degree, velocity increases. Velocity is positive, and the shape it makes this kind of shape concave. So acceleration is also positive, and velocity positive, acceleration positive, both are positive. Velocity increases. So we have one more example from NCRT book. Suggest a suitable physical situation for each of the following graph. So graph number one, it is having t somewhere here. T is less than 0. Fine. Let's see from graph number A. So initially, when we are talking about this, yeah, x is 0. It is rest. Wow. Then for A, let's check velocity. Let's check velocity. So for this is less than 90 degrees. So velocity is positive. So velocity increases, velocity increases. Then if we go with this graph, this theta is greater than 90 degree. So velocity decreases. If it crosses here, so it becomes 0 momentary. And then in the negative direction, it is going in the negative direction, increases. How? Then then it continues. Negative direction, it continues. Fine. So this is A is very simple. Now B. So velocity starts from V, graph B. Velocity is starting from V and linearly it is decreasing. So similar of the here line B, if you see this B similar to the line B, that means for this line it is like that, having a similar kind of slope but somewhat more steeper. So it is having this angle. It is this initially, if you see this initially, so it is having negative velocity, and then it is also having, it is not negative velocity, it is positive velocity. See here, this is above V, that means it is positive velocity is going towards negative velocity. Fine, it is having a straight line, it is having a straight line. So from positive velocity, velocity becomes 0, and then negative velocity. Velocity, positive velocity, then 0, then negative. Then again, magnitude reduces, positive velocity, 0, negative. And continuously magnitude reduces, right? So it is simply an example of a ball falling freely from the height. If you just, right, ball is fall freely and it strike on the ground, then it bounces back up to some height, then it falls, again bounces back, then it falls like that. It is just a ball rebound multiple times, and that is the shown in this. And the graph number C, we can see initially it is acceleration is zero. Initially acceleration is equal to zero, and then suddenly at sudden this point, acceleration suddenly increases like a pulse increases, become maximum, and then it goes to zero. So it is then suddenly what acceleration increases, then very small, and then becomes zero. Example is like that: batsman hitting a ball, so velocity, maybe fast bowlers is throwing or a bowling, we can say rather, it at some speed 150 kilometer per hour. Oh wow, one top speed, and then ball hits by a batsman, and that suddenly it increases to 500 kilometer per hour speed. Oh wow, what a capacity! And then it return to its original one, and wow. Another one is that in case of football is traveling horizontally when hit ball or gets kicked by a player. So if it is kicked by a player, so player gives its energy and suddenly there is a. So let's have example number 32. Figure gives xt plot of a particle executing one dimensional simple harmonic motion. So we will study simple harmonic motion in the chapter number 14. Fine. Give the sign of position, velocity and acceleration variables of the time t is equal to zero point 0.3 somewhere here. Yes, it is somewhere here 0.3, 1.2, here it is 1.2, and minus 1.2, somewhere here it is minus 1.2. This is from the NCRT. Let's just check. So at point 2, at point 2, this is point 3, sorry. If we take this, so theta is greater than 90, and point 3 is here. X position is below this line, therefore x is negative. What about velocity? Velocity is also negative because theta is greater than 90 degree, so velocity is also negative, and the shape, it is like that, con concave, so acceleration is positive, so acceleration is positive. Now next is point 1.2, 1.2, 1.2, x is positive, directly visible. Then let's take slope, tangent. Theta is less than 90 degree, theta is less than 90, so velocity should be positive. Velocity should be positive, and acceleration for that concave shape, acceleration is negative. Right? This convex shape, acceleration is negative. And at negative, let's remove everything. At negative 1.2, somewhere here minus 1.2. X is negative, it is visible directly. X is below this axis, so it is negative. What about velocity? Let's take here. This is the theta less than 90, so velocity is positive. What about acceleration? It is acceleration concave. That means acceleration is. So here we have one more example. Example number 33. Oh, how many examples we have? We have plenty of examples. Figure gives the xt plot of a particle in one dimension motion. Three different equal intervals. So time is given equal, in which interval is the average speed greatest, and in which it is the least. So maximum and minimum we need to find out. That's the solution. See the slope we need to find. We need to just find slope. This is the slope theta for 1 and 2, and this is the slope if you see here, right? So if you see the slope theta 3, it is having theta is having greater than 90, so it is negative. It is negative, right? It is negative, and it is also having maximum. It is also having maximum. Slope is maximum, but in negative direction, fine. Then shape is concave, right? Shape is concave, so acceleration is positive, hence velocity decreases. That may not require even, fine. So shape of the interval 1, here, if you see the slope of the interval 1, it is having minimum slope if you compare with others. So this is theta, right? So it is having minimum speed. This is having minimum speed, and this slope is maximum. Therefore, it is having maximum speed. V max and V min. Then slope of interval number 2 changes from positive to negative. If it is asked, then you can say positive to negative. So velocity changes from positive to negative. You may check out this. So yeah, it was from NCRT questions. And you may have this. The second comment is additional. This second is additional for your knowledge, but it was only asked that average velocity, and this all we have. So here we have example number 34. So what it means? Figure gives a speed time graph. So this is the figure talking about. This is the story. The three equal intervals of time are shown. In the first, it is important here. In which interval is the average acceleration? See, this is the graph, speed versus time, right? So do not just misjudge. This is not x versus time, but it is speed velocity versus time, right? So slope gives acceleration. In which interval is the average acceleration greatest in magnitude? For acceleration, we just need to have slope. So slope of first, it is like that. Slope of second one, yeah, it looks much bigger compared to one, and slope C like flat. So yeah, of course, for the answer, the first one, slope of 2 is maximum, therefore it is having maximum acceleration. It is having maximum acceleration. So first answer is done. First is done. This is done. Now is in which interval is the average speed greatest? See, directly this graph is given for the speed. Now you need not to find the slope, right? It is directly given the graph. So here see, highest it is at point D, speed of the particle maximum at position D, and this is for the 3. Yeah, it is very easy. Then choose the positive direction as the constant direction of motion. Give the sign of velocity and acceleration in the 3 interval. Wow, this is question I love. So here velocity is positive. So if we take for this one, theta is less than 90, so it is V is positive. Yes, this is positive. Then here, if you just see this, so what happened? Theta is greater than 90. So here for this negative velocity, and for this it is flat. It is flat, right? Then positive acceleration in the interval of 1, right? As its slope is positive. If slope is positive, acceleration is positive. That we can get it very easily. For negative, if slope is negative, acceleration definitely it is going to be negative acceleration. Here it is positive. See, you can also identify with this, the velocity is increasing. Yeah, velocity, all velocities are positive. All the velocities are positive. How can we say velocities are negative for any of this statement? Right. So this was mistake. See, this is positive velocity. So all for all velocity is positive. For this Acceleration is positive for this, acceleration is negative, and this is for the acceleration, you can say 0, fine, for the momentary, right? So slope, and the last one is that where are the accelerations at the point A, B, C, D? A, B, C, D. See, all the points are having flat position, flat portion, flat portion. This is 0, this is 0, this is 0, this is 0. Slopes are 0, acceleration is 0. For that, slopes are 0, accelerations are 0.